So we're finishing up this problem where we have the decay of the stock index. So we want to find the decay rate. So e to our exponent power should be equal to our decay factor of 1 minus r. So first thing I have us do is factor out that t from the exponent. So now we can just say that 1 minus r is equal to our e to the negative 0.0381. So solving for r is going to be 1 minus e to the negative 0.0381. Now to put that into your calculator, get out. Okay, 1 minus e to the power. You'll notice on the left next to 4, it says ln, and then in blue above that, it says e to the x. So that's what we're going to use to raise e to the power 0.0381, and we get 0.037. So writing that as a percent, we move that decimal over twice. It's about 3.7% decay rate. A paleontologist uncovers a fossil of a saber-toothed cat in California. The paleontologist analyzes the fossil and concludes that the specimen contains 15% of its original carbon. So the percent of the original carbon in the specimen after t years can be modeled by the given function, where t is the number of years after the specimen died. So first thing we want to do, using a graphing calculator to determine the age of the fossil, and then determine the decay rate of the function. So seeing that it's e to the negative exponent should tell us that it is a decay rate. Now, what we're going to do now, we know that it contains 15%. So we're going to plug in our function, which is 100, right? Yep. 100, and then e to the negative 0.00012x. And then since it's 15%, we're going to make that y value 15. Now, knowing what I know, we're going to have to seriously change our windows. So this is going to be 15,500. And this is going to be 16,000. And I'm going to have it go by 50s. And then with the y values, we're looking for 15%. So I'm just going to put it between 10 and 20 with a scale of 1. So I should see both graphs here. They're not going to be super up close. That decay rate is pretty small. But we're just looking for where they intersect. So if we hit second trace, and number 5 is the intersect, showing what our two curves are. So our intersection is about 15,809, or about 15,810 years. So to find the decay rate, we would say 1 minus r because it's a decay. That should be equal to our e to our negative exponent. So our value r would be 1 minus e to the negative 0.00012. If you plug that into your calculator, you'll end up getting about 0.012%.